I offer my humble pranam at the lotus feet of Bhagavan Sri Satya Sai Baba. Welcome to video lecture on microprocessor laboratory. Today lecture I am going to explain about memory segmentation. See, if you want to design any computers, we have some important components like microprocessor. It is also called central processing unit. We need input device like keyboard. We need output device like monitor, and then we need memory. That's a primary memory. The primary memory consisting of RAM and ROM. That's a random access memory. It's also called read-write memory. If you want to store any program, we require this. If you want to run even a simple program, the code must be in RAM. And if you want to store some information permanently, that must be in read-only memory. Therefore, so this is an input device, output device, memory, and this is microprocessor. Then if you want to transfer data from keyboard to microprocessor, microprocessor to output device, or from memory to microprocessor, or from microprocessor to memory, we need a lines. That is we can call it a bus. What is bus? The bus is a group of communication lines. Therefore, if you want to transfer the information from microprocessor to any external devices, we require a communication lines called bus. Therefore, here, so this is a bus, here this is also a bus, that is a bus, here this is simply we can call it as system bus. Therefore, with the help of this bus, we can able to transfer data from input device to microprocessor, or microprocessor to output device, or from microprocessor to memory, or from memory to microprocessor. Therefore, if you want to design any computers, at least we need these minimum components. Therefore, we can call it a block diagram of a computer. Then I am talking with respect to 8086 microprocessor. Therefore, basically the system bus consisting of three different types. So we know the bus is nothing but what? The group of communication lines is called bus. Therefore, here we have three different type of buses. Address bus, it carries address. Data bus, it carries data. Control bus, it carries timing and control signals. Then here I am talking with respect to 8086 microprocessor. Therefore, if you go for 8086 microprocessor, we have 20 address lines, 16 data lines, and so many control signals. Now here there are 20 address lines in 8086 microprocessor. See, by using a single line, see these are the lines. By using single line, we can able to carry one bit of information. Either it may be 0 or it may be 1. Therefore, using single line, we can carry 2. That is 2 power 1 is 2. By using two lines, we can able to carry how many information? 4. 0 0 0 1 1 0 1 1 like this. Therefore, if you go for 8086 processor, we have 20 address lines. Means at a time we can able to carry 20 bit of information, means 20 bit address. Therefore, how many possible address we can able to carry? That is, the first address is all zeros, that is 20 zeros. The last address is 20 ones, the last combination. Therefore, here we can have 1 million combinations. How many combinations? We can have 1 million combination. Means with the help of 20 address lines, we can able to address 1 million locations. Here I have written in three different number system. It is in binary number system, 20 bit address. It is in hexadecimal number system, and it is decimal number system. So we know how to convert from decimal to binary to hexadecimal. We have to make a group of 4 bits, 4 bit, this 4 bit, 4 bit, 4 bit, 4 bit. Actually here there will be mistake. Actually this is nothing but what? 0. This is 1, this is 2, this is 3. I have to change this one actually. Therefore, with the help of 20 address lines, we can able to carry how many information? Say 1 million informations. Means what is the memory capacity of 8086? The main memory capacity of 8086 microprocessor is 1 MB, 1 megabyte, 1 million locations. Therefore, so tell me, who will decide the main memory capacity of the processor? Suppose if you go for 8086 microprocessor, we have 20 address lines, 2 power 20, the memory capacity is 1 MB. In the same way, if you go for 386 microprocessor, we have 32 address lines, that is 32-bit address. Therefore 2 power 32 we can address 4 GB of main memory. Therefore the address bus decides the main memory capacity of that particular microprocessor. Therefore here I am talking with respect to 8086 microprocessor. Therefore with the help of address lines, 20 address lines, we can able to address how much of memory? 1 MB of memory. Now this is a memory map. We know that the size of each memory location is 8-bit. It is in binary 1001, that is 9, 0110, that is 6, 96 is the data. It's 8-bit data, it's 1 byte. It's a data. And each and every location has its own address. Like location number 0, location number 1, location number 2, 3, 4. Okay, in the same way this is in hexadecimal. Okay, so if you want to represent address in hexadecimal form, it requires how many X digit? 5 X digit. 1, 2, that is here 1, 2, 3, 4, 5. So 5 X digit, that is nothing but 20-bit address. Therefore what is the address width of 8086 microprocessor? 20-bit address. For that we can call it a physical address. For this we can call it a actual address, physical address. Therefore 20-bit address. And what's the size of each memory location? That is 8-bit. Therefore if you go for 8086, we can have 1 million locations. The first address is zeros, 5 zeros. The last address is F. That is actually, if you want to convert this into binary, this requires 4-bit, 4 ones, 4 ones, 4 ones, 4 ones, 4 ones. Therefore totally we can say it's a 20-bit. Totally 20 ones are there. That gives last address. Therefore tell me, what is the main memory capacity of 8086 microprocessor? That is equal to how much? 1 MB. Therefore the main memory capacity of 8086 microprocessor is 1 MB. Who will decide? The address bus decides the memory capacity, the main memory capacity. Okay, next I will come back to a data bus. Say in the case of 8086 there are 16 data lines in 8086 microprocessor. Therefore the data bus most of the time decides the word length. What is the meaning of word length? How many bits we can able to process at a time, how many bits we can fetch, how many bits we can send, and how many bits we can able to perform manipulation, different type of operation like arithmetic and logical operation. Therefore the word length of 8086 microprocessor is how much? 16-bit. Who will decide? That is data bus. Actually the data bus is a bidirectional. See the arrow mark, it's a bidirectional. We can able to transfer the data from processor to external devices or from external devices to microprocessor. Therefore what is the first data? All zeros. What's the last data? All ones. First data is all zeros, the last data is all ones. This is 0, here 1, here 1 0, here 1 1, so there is some mistake. Okay, 0 1 2 3. Therefore using 16 data lines we can able to carry 65,536 datas. Okay, therefore most of the time the data bus decides the word length. Therefore the word length of 8086 microprocessor is how much? 16-bit. What is the meaning of word length? What is the meaning of word? Means how many bit we can able to manipulate at a time. That is, we can able to perform 16-bit addition, 16-bit multiplication, 16-bit division, 16-bit all logical operations. Therefore how many data lines are there in 8086? We have 16 data lines. Okay, now just see, it's a block diagram of complete the microprocessor with the external memory. Now here this is a microprocessor. The microprocessor means inside we have registers. We know that we have totally 14 registers. Here 4 data registers, set 2 index register, 2 pointer register, and 4 segment register, and there will be instruction pointer and flags, and there will be a flags. This side we have memory. What is the main memory capacity of 8086? 1 MB. That is 1 MB. We will decide this address pins, address bus. Okay, in the case of 8086 we have 20 address lines. We can say from A0 to A19, 20 address lines. How many data lines? Said 16, D0 to D15, and so many control signals, RD bar, read signal, write signals. okay, and interrupt signals, reset signals, power signals. So many signals are there. Just I mentioned here only two signals, RD bar and WR bar. RD for read operation and WR for write operations. We have two signals. My question is, how I want to transfer data from memory location 21,000 to your processor, microprocessor. So how many steps involved to transfer data from memory to microprocessor or from microprocessor to memory? Actually, we require three steps. What is step number one? The step number one is the processor will place the address on the address bus. Address bus carries the address. Okay, that is decoded by a decoder. What is the function of decoder? It selects only one location out of 1 million. Okay, this is step number one. So in this example, we have 21,000. Suppose I want to transfer data from 21,000. What is the content of 21,000? 49 to microprocessor. Therefore, the 21,000, that is address of the memory location, is placed on the address bus, that is from A0 to A19, that is 20-bit address. Address bus carries this 21,000, that is given to the decoder. That is given to what? Decoder. So what is the function of decoder? The decoder select only this location, only location number 21,000. That is step number one. What is second step? We want to transfer data from memory to microprocessor. Means we want to perform which operation? Read operation. By the time, so there will be a control unit within this microprocessor. It makes RD bar low and WR bar high. Means read operation. Once this signal is low and this signal is high, that indicates what? Read operation. So once RD bar is low and WR bar is high, it reads the data from specified location and plays the data on the data bus. Okay, in this case I am talking about 8-bit data. That 8-bit data is placed on D0 to D7. Then this carries data and brought inside the processor. Therefore, if you want to transfer data from memory to microprocessor or from microprocessor to memory, we require three steps. What is first step? Select the location. What is second step? Identify the type of operation, read or write. What is third step? Actual data transfer. Therefore, to implement these three operations, we require three different type of bus. Which are those? The first one is address bus to implement step number one. Then the second one, somebody has to be there to decide type of operation, read or write. We will going to decide control signals, say in this case RD bar and WR bar, and somebody has to be there to carry the data from memory to processor and processor to memory. That is taken care by a data bus, that is T0 to D15. Therefore, if you want to transfer data from memory to processor, processor to memory, we require address bus, data bus, control bus. Address bus carries address, data bus carries data, control bus carries timing and control signals. We have so many signals. Just here only I mentioned only two signals, that is RD bar and WR bar. Any doubts here? Kaushik, Kavana? Any doubts in this case? Okay, shall I proceed? Just I will repeat once again. That is, how many steps we require? Three steps. That is, processor will place the address in the address bus carries the address. Okay, that is given to the decoder. Decoder selects only one location out of 1 million. That is step number one. What is second step? Then there will be a control unit. That is a control unit inside microprocessor. The control unit decides type of operation. So in this case, assume it makes RD bar low, WR bar high for read operation. Then it reads the data from the specified location, selected location, and that data is placed on the data bus. Either it may be 8-bit data or it may be 16-bit, maximum 16-bit. Then data bus carries the data and brought inside the processor. This is for we can say memory read operation. How to write the data into memory? In that case, suppose I want to write the data into the last location. Assume the data is available in the register AL. The step number one is, once again, Say processor place the address in the address bus carries the address. Okay, then that is decoded by decoder, then select the last location, let it be. That is step number 1. What is second step? Then the processor will place the data on the data bus carries the data and it is available here. What is third step? Now your RD bar is high and WR bar is low, then whatever the information we have on the data bus, that is written into the specified memory location. Is it clear? Okay. So therefore this is the way of transferring data from memory to microprocessor and microprocessor to memory. The question is, we know that in microprocessor, in 8086 microprocessor, we have totally 14 registers and the size of all the registers are 16-bit. But what is the size, address size or address width of 8086? That is 20-bit. That is all about 20-bit. My question is it possible to store 20-bit address, that's a 20-bit address, in 16-bit register? It is not possible. It's not possible because we don't have even single 20-bit register in 8086. All are 16-bit. Say all are 16-bit and we have 8-bit registers. But there is no single 20-bit register to hold the address. But who is going to provide the address of the memory location? That is microprocessor. What is microprocessor? Microprocessor in the sense registers. Then what is the size of all the registers? 16-bit. All are 16-bit. Now my question is it possible to store 20-bit address in 16-bit register? It is not possible. That's why we had to go for a concept called the segmentation. Segmentation. Okay, we have to go for what? The concept called segmentation. What is the purpose of going for segmentation? We know that we have 20 address lines, that is 20 pins are there. Okay, actual address, the physical address of the memory is 20-bit. It is not possible to store 20-bit address in 16-bit register. Therefore, we have to find some means of storing this 20-bit address. Okay. The next thing is, we know that we have registers like BX, SI, source index, destination index, stack pointer, base pointer, and there will be a instruction pointer. There will be instruction pointer. What is the size of all these registers? All are 16-bit. All are 16-bit registers. Say bit number 0, bit number 15. It says all are 16-bit register. So what is the maximum number we can store? The first number is 0. Say 16 zeros. Say first number is 0. What is last number? Say we can say 16 ones. That is equal to F in hexadecimal. That is equal to 65,535. Means we can able to store 65,536 possible information using 16-bit register. Therefore, if you go for 8086 microprocessor, we know that we have 1 million locations. The address width is 20-bit. Address width is how much? 20-bit. Then is it possible to store the 20-bit address in 16-bit register? It is not possible. Using 16-bit register, we can able to address only this much. Only this much. That is 64 kilobytes. Means how can you get this number 64 kilobyte? That is 16-bit. 2 power 16 means we can able to address 65,536. I want to express in terms of kilobytes. So divide this number by 1024. Okay, what we will get? We will get 64 kilobytes. That is 1 kilobyte equal to 1024 bytes. Therefore, if you want to express this in terms of kilobytes, divide this number by 1024. That gives 64 kilobyte. Means that is with the help of 16-bit register, we can able to address only 64 kilobyte of memory. But if you go for 8086, what is the main memory capacity? We have that is 1 MB. That is 1 MB is nothing but 1024 KB. 1024 KB equal to 1 MB, but with the help of SI, DI, SP, BP, okay, or some BX, that is with the help of this we can able to address only 64 kilobyte. The question is then how to address the complete 1 MB memory. 1 MB memory. In this case we have to go for a segmentation, or we can say block approach. We have to divide the whole memory into so many blocks. So just we can see the next slide. Here we know that this indicates address lines. How many address lines are there in 8086? 20 address lines. Therefore 2 power 20 we can have this many locations. 1 MB, that is nothing but 1024 KB. What is this? 1024 KB. We have this much of memory. We know that it is not possible to address 1024 KB by using 16-bit register. But with the help of 16-bit register we can able to address only 64 kilobyte. Therefore what we are going to do is, that is here that is 2 power 20, 1024 KB. Therefore with the help of one 16-bit register we can address 64 KB. Therefore divide this number by this. Therefore we will get, that is something called blocks, 16 blocks, or we can say segments. I am dividing the whole memory, that is 1 MB memory, a 1024 KB memory, into how much? 16 blocks. What is the size of each block? 64 kilobyte. Therefore with the help of 16-bit register I can able to address. We can able to address how much memory? 64 KB. That's why we are dividing the whole memory into how many blocks? 16 blocks. Say this is one block, 64 kilobyte. Okay, we can say segment 0 or block 0. So one more block, segment, this is another 64 kilobyte, that is segment 1, block 1. Next, like this is another 64 kilobyte, the segment 2 or block 2, etc. Okay, then last segment is, that is also 64 kilobyte, that is segment 15. It's also called say block 15. Therefore from block 0 to block 15, or we can say segment 0 to segment 15. From 0 to 15, how much? Totally we have, totally how many blocks we have, how many segments we have? Totally we have 16 segments. What is the size of each segment, or what is the size of each block? 64 kilobyte. What's the size of each block? 64 kilobyte. Therefore 16 into 64, that becomes 1 MB. That becomes what? 1 MB. Therefore segments or blocks are addressed by segment registers like CS, DS, SS, ES. What is the purpose of using this 16-bit register? It is used to address, what? Segment. Okay, we have 16 segment. Depending upon your requirement, we have to choose some segment. That is, we are going to select. So which register we require to choose the segment. To select the segment, that is segment registers. That is, we have 4 segment registers in 8086: code segment, data segment, stack segment, and extra segment. That is, totally we have 1 MB memory, 1 megabyte memory. 1 megabyte memory. How many blocks we have? 16 blocks. What is the size of each block? 64 kilobyte. Then what is the complete size? 64 kilobyte into 16, that becomes 1 MB. Therefore somebody has to be there to give the segment address. Okay, somebody has to be there to address this segment or blocks. We are going to take care of this, that is segment register. Okay, next, in a given program I need only 4 blocks, or I need only 4 segments. Instead of using all 16 blocks, 16 segments, just I want to use only 4 blocks, 4 segments. So that's why out of 16, so in the previous case we have 16, out of 16 just I am considering only 4 blocks. Only 4 blocks. So I'm going to reserve one block for program memory. It means to store only program. What is the size of this? 64 kilobyte. Means out of 16 blocks, I'm going to use only one block to store program. What is the size of this? That is 64K. Then we are going to use one more block to store only data. For that we can consider data memory. Once again the size is 64 kilobyte. Then we are going to use one more block to store some temporary information at the time of execution. That is also 64 kilobyte. And sometime we want to perform some string operations, string manipulation operations. By the time we are going to use one more block to store what? Strings. By the time we can consider extra memory. The size of extra memory is also 64 kilobyte. Therefore, how many blocks we can have in 8086 memory system? We can make 16 blocks. But out of 16 blocks, for a given program, we require only 4 blocks. That is program memory to store program, data memory to store input or output data, and stack memory to store some temporary information at runtime. And if you want to perform any string manipulation, we have to go for extra memory. Then somebody has to be there to give the block address. Suppose if you go for an apartment, say something like block A, block B, block C, block D. Okay, suppose assume block A contains 100 houses, block B contains 100 houses, block C contains 100 houses, and block D contains 100 houses. Okay, suppose I want to meet somebody who is staying in block B. Then I will go to block B. This is a block B. But within block B, what happened? I want to meet somebody who is staying in house number 100 or house number 20. Therefore, say B20. What is B20? B is a block and 20 is the house number. Therefore, you are not supposed to go for A block. You are not supposed to go for C block. You are not supposed to go for D block. First, you have to go for B block. But B block contains how many houses? 100 houses. 100 houses. Therefore, we have to go for which house? The house number is our door number is what? 20. Therefore, we have to go to, that is house number 20. The same concept here also. Clear? Therefore, block A, block B, block C, block D. So assume it's an apartment. Okay, we have 4 blocks. Each block contains 100 houses. And how many houses we have in this apartment? So we have 400 houses. 400 houses. 100, 100, 100, 100. Okay. Therefore, if you want to meet somebody who is staying in C block, assume the door number is C25. C25. Therefore, you are not supposed to go to A block. You are not supposed to select B block. We have to select which block? C block. Under C block, house number 25. In the same manner, somebody has to be there to give the segment address or block address of program memory. So in this case, that is right. We just assume that what is the segment address of this? 1000. This 1000 is constant for this complete. Okay, suppose if you go for a block A block A is constant for all 100 houses. A0 to A99, or we can say A1 to A100. Clear? Therefore, here, what is the address of this block? 1000. Okay, what is the address of this block? Let it be 2000. What is the address of this block? 3000. What is the address of this block? 4000. Suppose if you go for a apartment, you used to give some other names like block A, B, C, D. In the same way, here I am going to give some address. The size of the address is 16-bit. This is a segment address, or we can call it a block address. What is the segment address of this program memory? Just I assume 1000. What is the segment address of data memory? 2000. What is the segment address of this memory? 3000. What is the segment address of this? 4000. Okay, once if we come to this, how many houses are there, or how many memory locations are there in this? We have 65,000 5 and 36. Okay, therefore somebody has to be there to hold this address, therefore if it is a program memory, therefore we are using CS. What is CS? Code segment. What is the size of code segment? 16-bit. What is the purpose of using this 16-bit register? To store the segment address of program. In the same way, for data memory we are using DS. It is also 16-bit. Then for stack memory we are using SS. For extra memory we are using ES. Therefore we have 4 segment register in 8086. All are 16-bit in size. The purpose of using this segment register is to hold the beginning or segment address of that block. It is analogous to like apartment: A block, B block, C block, D block. So what is block A address? 1000. What is B block address? 2000. C block address 3000. D block address 4000. But in our 8086 we are going to reserve some register to store this. And one more important thing is this 1000 is constant for throughout this block. Like apartment, A block, it remains same for 100 houses. Okay, B contains 100 houses. This B is constant for this 100 houses. In the same way, say here, once if you enter into this block, we have 64 kilobytes of memory. Okay, for all the 64 kilobyte of memory, the block address, segment address remains same. That is, here the address is from 0000H, 16-bit address. Here FFFH, 16-bit address. Okay, with the help of 16-bit address, we can able to address 65,536 or 64 kilobyte. Okay, now here we have two address. This is 16-bit address, this also 16-bit address. For this address, we can call it as segment address. For this address, we can call it as offset address. With the help of segment address and offset address, we can able to go to particular location and we can able to fetch the code. We can fetch the instruction. Okay, for execution purpose. Therefore, if you go for this, and here to hold segment address we are using code segment register. In the same manner, to store this address, any one of this address, somebody has to be there. We are going to use instruction pointer. Therefore, what is the size of IP instruction pointer? It is 16-bit. What is the size of CS? 16-bit. Therefore, I am dividing the 20-bit address into two parts. We know that it is not possible to store 20-bit address in 16-bit register. We are dividing 20-bit address into two parts. One is called as segment address, another one is called as offset address. What is the size of segment address? 16-bit. What is the size of offset address? 16-bit. Totally 32-bit. For this address, we can call it as logical address. Here, there will be physical address, logical address, segment address, and offset address. Here 4 keywords are there: segment address, then offset address, then logical address, then physical address. What is logical address? CS, then the IP. This address, segment address, and 16-bit, and this is 16-bit, 32-bit. For that we can also logical address. What is segment address? 16-bit. This called segment address. This segment address is common, constant for this complete block. What is offset address? It is the address of individual locations. Okay, that is offset address. So in the next class, I am going to explain how to generate a physical address. So now here, the segment address, offset address. If somebody has to be there to store offset address, who will going to take care of this? That is instruction pointer. In the same way, here data memory. Okay, it is 64 kilobyte. Starting address 000H, 16-bit address, last address FFFH. Therefore, here we are going to use either BX, SI, or DI to store the offset address of data memory. You are not supposed to use IP for this purpose, or you are not supposed to use this register to store the offset address of program. Here, if you go for a apartment concept, suppose there will be door number A25. A is a block, 25 is the door number. Here also you can see 25, here also 25, here also 25. Then how to differentiate? With the help of block. L25, A25, B25, C25, D25. A25 means first we have to go for block A, then location 25, house number 25. Therefore, the segment address is very important. Suppose if I have only segment address, I have only block A, I will go to A block, but I don't have this address. It's not possible to go to that particular house. In the same manner, suppose we have 25. Here also we have 25, here also we have 25, here also there will be 25, here also there will be 25. Then we have 4 options. Okay, how to choose? That is also a problem. Therefore, we need both segment, means block address, as well as offset address. With the help of both, we can go to particular location. Either we can fetch code, or we can fetch data, or we can write data, or something like that. Therefore, here, that is data memory. What is the size of this block? 64 kilobyte. Who is going to give the segment address? Data segment. Who is going to hold the address of individual locations? We can say offset address, that is BX, SI, DI. What is the size of this? 16-bit. What is the size of this? 16-bit. Okay, it's not possible to use IP for this, and it's not possible to use, you are not supposed to use this for this. Okay, in the same way, here once again 64 kilobyte. Here we have SP or BP. SP stands for stack pointer and BP stands for base pointer. Both are 16-bit register, 16-bit register, 16-bit register. Both are 16-bit register. Therefore, with the help of SP and BP, we can able to store offset address. In the same way, here also 64 kilobyte. Then here it is used in string handling, string manipulation. In that case, we have to go for DI, that is destination index. Any doubts here? Okay, therefore out of 16 blocks, we are using only 4 blocks. We can use any block as you like. Okay, it may be 6,000, or it may be 7,000, it may be 8,000, it may be 9,000. Okay, whatever it may be, some other address also. Okay, therefore here CS, DS, SS, ES use it to store segment address, and this is for offset address, and each and everything is reserved. You are not supposed to use SP, BP for data, or BX, SI, DI for stack, or IP for this, or this for this. It is fixed. Any doubts? Therefore, we are dividing the physical 20-bit address into 2 parts, segment and offset. And somebody has to be there to hold segment address, that is this registers, and somebody has to be there to hold offset address, this other registers used. But if you go for a program memory, CS, we have to store segment address in CS only, and offset address must be in IP. In the same way, we have to store segment address in DS, and offset address must be here. And segment address of stack memory in SS, stack segment, and offset address of stack memory either in BP or in SP, depending upon type of addressing mode. If you go for a string manipulation instructions, we have load string byte, store string byte. We have so many string instructions. In that case, that is, we have to use this memory. Then the segment address must be in ES, then offset address may be in DI and as well as in SI, something like that. Any doubts here? Okay. Now for this we can call it as segment address. For this we can call it as offset address. Okay, that is 16-bit put together we can call it a logical address. I used to say CS:IP, DS:BX, or DS:SI, DS:DI, or SS:SP. That's a way of mentioning logical address. SS:BP. In the same way, ES:DI. That's a way of mentioning logical address. What is physical address? 20-bit. What is segment address? 16-bit. What is offset address? 16-bit. Any doubts here about segmentation? Therefore, it's not possible to store 20-bit address in 16-bit register. Therefore, we are dividing the 1 MB memory into so many blocks. The size of each block is 64 kilobyte. We have 16 blocks, and each size of each block 64 kilobyte. That becomes 1024 KB kilobyte. That becomes 1 MB. That is the concept. Okay. Say if you for more videos you can visit my website. Okay, thank you.